Hey everyone, in this video let's take a look at question 68, text justification on Leetcode. So in this question we're given an array of strings called words and a maximum width, what you call maximum width, and you want to format the text such that each line has exactly maximum width characters and it is fully left and fully right justified. What we want to do is we want to pack the words in a greedy approach, that is, pack as many words as we can on each line, and then we want to separate out the words with spaces so that there's exactly max width characters on a line and it's left and fully right justified. Extra spaces between the words should be distributed as evenly as possible. So what that means is that if the number of spaces on each line does not divide evenly between the words, the empty slots on the left will be assigned more spaces than the empty slots on the right. Finally, for the last line, it should be left justified and no extra spaces should be between the words. So let's take a look at what exactly this means through an example over here. So I want to clarify what exactly left justified and right justified means here. So we have our words here, which is, this is an example of test justification, and we have our output over here. This you can see is left justified, is also right justified. What left justified means is that the first word is essentially at the start of the string. What right justified means is that the last word is at the right side of the string. Now, what it means to be fully left and fully right justified is that the words in the middle, they're actually going to be distributed so that the number of spaces that they need to take up is going to be as even as it can be. So what does this mean here? Well, if you count the number of characters here, it's going to be 16. And if we want to have left justified, it means that this is going to remain here, an is also going to remain here. But everything in between here, we have to kind of distribute 16 spaces. Well, not 16 spaces, but actually 8 spaces, right? Because there's 8 characters here, and so we have 8 spaces to distribute. And the best way in which we can actually distribute it is 1, 2, 3, 4 spaces here, and 1, 2, 3, 4 spaces here. Now, if you think about this really, the way in which we're distributing the spaces, we're actually only going to be distributing the spaces between, so if each line has n characters, we're actually only going to be distributing between like 2 sets of words, right? 2 sets of words. So if you really think about it, we're only going to be distributing spaces between like n-1 words here. We're actually only going to be adding spaces to this. So this is initially just this, and then we increment it to include all these spaces. And also is initially just this, and then we add in all of these spaces to increment it so that it becomes like fully justified. Now, we're not going to do this to an, because if we do it to an, then it's going to be like something like this, which is not what we want. It's not going to be right justified in that manner. On the last line, because the last line is only left justified, let's say we had a word here like just instead, right? If we had just, and let's say we had something like a, and this was the last line, in this case, it's going to be something like this. What's going to happen here is that all of these spaces are just going to be appended right after the last word. So it's actually not going to be right justified, but it's going to be left justified. And you can notice here that when it's left justified, the amount of spaces between this, as we can see over here, for the last line of text, it should be left justified and no extra spaces are between the words. So we're actually not going to spread this out like we did in the other examples above. In this one, all we're going to do is we're just going to add in one line or one space between each of the words over here. So that's essentially like what left justified means, what right means, what we're going to do in the last line, and how we're going to distribute the spaces. Now let's maybe talk about how we're actually going to go about doing this algorithm, right? Now, in these types of questions, when you have like a set of words that you have to go through, you kind of have to think to yourself whether it's going to be a simulation or whether it's just going to be a simple iteration, right? Now, what do I mean here? Well, a simulation is a kind of algorithm in which like you have a set of kind of words or an array, and you want to repeatedly go through them, and this can be like, you know, millions of times, but obviously you're not going to loop millions of times. So what you do is you simulate. Maybe an example of this is like, you know, let's say we have like 20 rows and we want to see how many times we can fit the entire sentence, you know, on the page, for example. So in that one, like, you know, this is one way in which we can fit it. And I guess this was like justification here, right? And then maybe like this, and then down here it would be like is an example. So this would go down and it will go down like many rows, right? And then maybe near the end it'll be like, okay, so you finish your sentence like 3 or 4 times, so that would be your answer. That's an example of simulation, because we're actually not going to be iterating like, you know, many times, but we're actually just going to simulate the result. We're going to figure out a clever way to do it. this is actually an iteration problem because we only have to go through it once. And so what we're going to do is we're actually going to go through the list of words and we're going to figure out like if we can add it to the line or not. And so this is this type of problem. And once you do like this type of problem, then you can actually relate it to other types of problems. But I think this is a good foundational question that we should go about doing. So the question is really like, how do we figure out like how many words can be added to each line, right? So let me just maybe remove all of this and go back to our initial example that we had. So this was the example over here, right? What we really want to do here, if you think about it, is we want to figure out what should be added to each line, or rather the number of words that should be added to each line. Once we figure out that on the first line there should be 3 words, then what we can do is when we try to add in the 4th word, we can see that it's going to cause a problem. It's going to cause an overflow. So in this case, what we're going to do is we're going to take our words, which it's just going to be, this is un, and they're actually going to go ahead and we're going to add in the spaces in between to create a valid string. And then we're going to move on to the next line and we're going to repeat that. And on the last line, we're going to do something a little bit differently, but it's like quite pretty much the same except for how we're kind of justifying it. So that's kind of pretty much how we're going to do this. Let's go ahead and look at the algorithm. And it's one of those questions where you kind of have to do it. It's not going to be really helpful to just kind of talk through it, but rather I feel like if you do it, it kind of resonates more. So let's take a look at how we're going to do this. Now, I think the first thing is I'll just declare my result variable. And so my result variable will essentially just be like something like this, right? So this is my result, it's my output. Another set of variable I need is like, I need to know how many words I can add on to each of the lines, right? So this is so this is like one line. So maybe I'll have like a variable called cur, and this can just represent the current line, right? What else do we need? Well, we'll see. Let's go ahead and start writing some code, and then we might see what kind of variables we need. But let's take a look at how the code will look like. So as I mentioned, this is known as an iteration, not a simulation. So what we're going to do is we're going to just go through the words just once, so for word and words. And now what do we want to do? Well, we want to essentially figure out like, can I add word to the current line, right? And it's usually, I think this is kind of the hardest part about this question is like, how can we figure out whether we can add a word to a line? And really, it doesn't help that cur is initially empty because you're kind of starting from scratch here, right? So let's just assume that cur had these 2 words inside, right? Let's say it had this, it also had is, and we're trying to add an, right? So trying to add an. What are the conditions in which, adding an would be valid? And what are the conditions in which it would not potentially be valid? So if you think about this, so what's one thing, right? So every single, if we didn't have this condition that like we had to like, separate out these spaces, one of the things we would need at least is that we need to be able to like add like one space, right, between the words. So we need to have something like this. This is n. This is like the minimum we need. Regardless of like, left justification or right justification, this is something like we need, right? So if you kind of think about it, the number of kind of words here, the number of words initially, it's just going to be 2, right? It's going to be this is, and we're going to add in an. Now, if you kind of think about this, the number of words is also equal to the number of spaces over here, right? Because that's how we're going to distribute out the words, at least like one space between the words. And so one thing I can kind of think of is I can say number of spaces is equal to the length of cur, which is the length of the line. So I know that number of spaces will be like definitely a factor, right? What's another potential factor that could be, part of whether I add it to the line or not? Well, we don't want to add like a massive word, right? Like we can't add in justification here because if you suddenly think about it now, like this string here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, it has way more than 16 characters. So technically also the length of the word takes into account, right? We have to take into account the length of the word as part of this. But what else? Well, I kind of already revealed it, but if you kind of saw what I did, I counted the total number of letters, right? I counted the total number of letters from start to end. And if you kind of think about that, we should have a number of letters. And so we have number of letters here. Now, if we add in all of these, and this is greater than max width, then we can't add it, right? We can't add it. Let's take a look at it again, because I think this is kind of one of the most important things. If we had just this, and then we also had is, and let's say this was our cur. Let's say our cur was something like this, right? If we had this, so what do we have? Number of letters here is equal to 6. Now, number of spaces is 2. Why is it 2? Well, it means because if we're going to add in something like an, then it means that we're going to have a space here. We're also going to have a space after is to add in an. So the number of spaces is going to equal 2. Now what can we do is we can see an, and basically the length of this, length of an is also equal to 2. And so can we add it? So it's 6 plus 2 plus 2, 8. And so this is actually, 10. It's actually going to be less than the maximum width. So this means that we can add it, right? An, we can add it like this. And then the number of letters becomes 8. And then the next time we do it, if we're trying to add in another word, the number of spaces at minimum we'll need. So this is really number of spaces minimum, right? The number of spaces minimum we'll need will be 3, because we'll need one between this is, we'll need one between is un, and we'll need one between un and the next word, whatever that might be. So this is kind of the main condition that we need to follow here. If this is false, it means that we can actually add a word. If it's not, then it means that this is kind of our final set of cur. This is our final line. And the next word that we're trying to add, which is example, we actually have to add it to the next line. So hopefully that's clear. And this is why we have these 3 conditions here. So it's the number of spaces plus the length of the word plus the number of letters in the current word, in the current kind of line itself. If we add all of those together and it's greater than the maximum width, then it's not allowed. Otherwise it is allowed. So let's take into account the case where it's allowed. In this case, it becomes very simple, right? Because all we have to do, and I'm going to remove this here, is we're going to append the current word to cur, and we're also going to increment the number of letters. Number of letters plus equals length of word. Now let's take into account the harder case, which is the fact in which we have something like cur is equal to this is an, right? So what are we going to do here? Well, what we need to do here is we essentially need to now create a string, right? We need to create some string, which is like is, and then something like an, and then we can just ignore these periods here. We need to somehow go from this to this. So what am I essentially doing? Well, what I'm essentially just doing is I'm just adding in the spaces, right? I'm just adding in the remaining amount of spaces. So I guess let's start with that, right? How do we calculate the remaining spaces? Like how many spaces we can actually add? Well, it's actually very simple, right? If I know that maximum width, the maximum number of letters on the line is this, and the number of letters on the line is something I already have. This is like 8 letters, right? And I have maximum width of 16. It means that I have 8 more spaces in which I can distribute some spaces. So I'm going to distribute here as well. So this is my remaining number of spaces. Now, the problem is how do I go about actually distributing these spaces? And kind of what we're going to be doing is we're going to be adding in the spaces to the list itself. So these are like list elements, right? We'll add in some spaces here, we'll add in some spaces here, and then we'll just join the string in the very end. Now, you might have kind of thought, why did I not add spaces to after an, right? Why did I only add it to these 2? Well, it's kind of what we talked about initially, about the justification, the left justification, the right justification. But essentially, we don't want to add spaces after, we don't want to add it for the last word itself, because then you're going to have spaces over here, and it's not going to be right justified. You only want to add it to n-1 words. So it's going to be just these 2 words over here. So that's one thing in which we should take into account. Now, another thing is, how do we actually go about adding the spaces, right? And I think more importantly is, what if there's an uneven amount of spaces? This time we have to add in 8 spaces between 2 words, which is easy, right? 4, 4. But what if it was something like 17? Well, in this case, or what if it was something like 9? Then we will have to add in 5 over here, and then 4 over here. So how can we do this? Well, this is one of those questions in which you kind of have to know the algorithm, or you get introduced to it the first time. But what we're going to use is the idea of a round robin. A round robin, essentially all it does is that it adds one kind of item to one item in the list, and then it goes to the next one, and then it goes back, goes to the next one, goes back, goes to the next one, etc. So if you kind of think about it, what we're going to do is we're going to have remaining, let's say it's 8, we're going to add in a space here, and then we're going to add in space here. Now remaining is 6. We're going to add in one more here, 4, one more here, 2, one more here, 1 or 0. And then in the case for something like 9 spaces, there's actually going to be one more added here, and that's it. That's the best we can do. So it's going to be a round robin type algorithm. So in those types of algorithm, it's actually very simple, and the logic is as follows. So you have the amount of spaces that you want to go through, and you do it while remaining is greater than 0, and you want to decrease remaining by 1. Now, what we want to do is we actually want to add the spaces themselves, right? So we know we're going to be modifying cur at a specific index, and we're going to be incrementing that space by 1. Now, what is the index in which we're going to actually do this, right? Like, what is the index? So the index. So what is the index going to be? Well, one of the things about round robin is like you're going to be going in the same array again and again and again, right? We're index 0, index 1, index 0, index 1, index 0, index 1. Remember, we're not adding it to the last index. So it's going to be 0, 1, 0, 1, 0, 1. So it's going to be repeating every single time. So we know there's going to be some sort of mod operator, right? So what is the index going to be in this case? So if you kind of think about it, the index in this case is going to be, so we need some sort of pointer I, right? Like we need to kind of go through the array itself. So we'll have some pointer I over here, and we'll increment I every single time. So let's say initially I is 0, right? If I is 0, then what we want to do is we want to remain on the 0th index. If I is 1, we want to come to the first index. If I is 2, we want to go back to the 0 index. If I is 3, we want to go to the first index, etc. again and again and again. So if you kind of think about it, what it's going to be I modulus what? Well, it's going to be essentially just modulus. Usually it's just the length of the entire array. Like if I want to do 0, 1, 2, 0, 1, 2, 0, 1, 2, if I want to do that again and again, it's just going to be length of cur, right? But in this case, because we don't want to go through the last element, it's going to be length of cur minus 1. It's going to be this. Now, what this is going to do is going to do 0, 1, 0, 1, 0, 1, etc. I is 0, I is 1, I is 2, I is 3, I is 4, I is 5. That's how it's going to alternate. One of the final things we kind of want to do is that what if there's only like one word that's left in the string, right? Like let's say this acknowledgement over here, right? Like it is left justified, but we still want to add in characters to the right of it, right? Because like that's one of the things we always need. We always need left justification, but if there's only one word, like we still want to add in characters over here. So how are we going to go about doing that? Well, that's actually it's kind of like a tricky edge case, but what we're going to do is it's actually going to be the maximum of this and then this. So what does this do? Well, if length of cur is 1, then this is actually going to be 0, right? So it's not going to add in any characters. So we need the maximum of 1 and whatever this is. So at minimum, if there's only one word in the list, it's going to add the spaces again and again to the end of the word. But if there's multiple, it's only going to add it to the first n minus 1 characters. So that's kind of what that is. And so we have to make sure to increment our index, which we do here. And then we also decrement our remaining, which we do here. And then now, at this point, cur is something like this. It is the value this, but it has all the spaces. It is the value is, and has all the spaces distributed as evenly as possible. And then the last value remains as is. So now the only thing left is to actually go ahead and join these, right? So we can say res.append, res is our actual answer variable, empty string.join cur. So this is our line. Now we're actually just going to go ahead and reset cur because it's going to be a new line. It's going to be like a new set of words. So we can reset cur to this. We can reset number of letters to 0 because we're going to now start with example, right? So we want to reset it. Now, if you kind of think about it, because we're resetting it, this else case actually has to be pulled outside because what it means is that we want to add an example over here, but example is not going to work. And so we're going to take in this is un, and we're going to fix that. And then now at this point, we're going to add an example. So when you reach here, the value is just something like this, right? So 7 characters here. So this is what like we're doing over here. Now we're almost done. We just have to kind of do the last part. And the last part is this final kind of string over here, right? Like this has to be just left justified. Now, what's going to happen in this case? In this case, let's say we're outside. Let's say we're outside of the main loop. Cur at this place, at this case, is going to be kind of the last line, right? So cur is last line, and I'm just going to remove these over here. So cur is last line. Let's say it's something like shall be, right? Let's say something like shall be. Well, all we want to do is we want to add in one space between the words. So what we can do is we can say last line is just one space joining the words. So now it's something like shall be. But now what we want to do is we want to actually go ahead and increment all of the ending kind of words over here, ending kind of spaces over here after be. So how can we do that? Well, it's kind of very simple if you think about it. All we're going to do is we're just going to check. We're going to check that if the length of the last, if it is less than maximum width, then last, what are we going to add to it? We're going to add a bunch of spaces after it. How many spaces? Well, it's going to be just max width minus the length of last, right? And so that's what we're going to do here. And really, if you think about it, we don't even need this check. We can just go ahead and just add this right as is, right? Because if this value is 0, it's not going to add in anything. But if there are some spaces to add, it will go ahead and add it. The final thing we'll do is we'll just add it to res. And then that should be our solution. So let's take a look and run it. And now we'll go ahead and submit it. And we see it working. So one final time, let's go through what we're doing here. So first thing we're doing is we're essentially going through all of the words, and you want to see if we can add the current word to the current line, to the cur variable. If we can, then we basically figure it out, and we append it, and we add in the number of letters. Eventually, there will be a point in which we can't add it. If we can't add it, based off of this condition over here, the number of spaces plus the number of words plus the number of letters, if that is greater than the maximum width, then what we do is we find out how many spaces we can add. We perform a round robin type algorithm, and then we combine our results, and then we reset cur and then num letters. And then finally, what we do is we append the new word and we update the number of letters, at which point it's going to be 0. And then finally, for the last line, we just go ahead and we just left justify it, and we don't do anything else. And then we just return that. So that's this function, that's this variable, that's this problem. I know it's a tricky one, but hopefully this all made sense. See you guys in the next one.